All right, so in the last video, we looked at the method to evaluate limits of type 0 times infinity. The first step is to bring one of the two factors down. You don't get to choose which one you bring down. You have to choose the correct one. There's one right one and one wrong one. So if you bring the wrong factor to the denominator, things will get worse instead of better. Here's an example where we pursue both options. All right, so let's say we want to evaluate the limit of x times e to the x, and I'm going to start by bringing x down. So limit as x goes to minus infinity, x e to the x. I'm going to bring the x down. I'm going to get 1 over x. It will turn out to be one of the types. In this case, it's 0 over 0. And if I take the derivatives, I'm going to get e to the x. Remember, this one is x to the minus 1, and so I will get minus x to the minus 2. And now my limit is minus x squared e to the x. So the power of x went from 1 to 2. So this is worse than x e to the x. All right, so if you see something like that happening, it means that you haven't picked the correct one. And so if you do this, what you should do is you should take the entire work you did and do this to it. It's useless. Well, maybe don't erase it if it's a test. It might be worth some points, but it's not going to help you get the right answer. All right, so if I do this, I would start over and I would say, well, I brought the wrong one down, so let me try with e. So I'm going to write it as e to the minus x. If I plug in minus infinity, this time I will get infinity over infinity. I will apply L'Hopital, take the derivative of the top, I get 1. Derivative of the bottom, I get minus e to the minus x. And so this will be 1 minus e to the plus infinity, 1. That's a huge number, but with a negative. But then I get 0. All right, so at this point, this is better. It's actually just minus e to the x if I bring it back up. So if I pick the x to bring down, the power went up. If I picked e to the x, the power went down. I don't have an x anymore. And so this one was the right call. That one was the wrong one. All right, so whenever you pick which one to bring down, there's definitely a hierarchy. So you should pick carefully, and there's a hierarchy of functions to pick. So let me put the better ones on this side and the worse. Right? So if you have a function that wants to live in the denominator, if you have something like cosecant of x, if you bring it to the denominator, you'll have sine, which is better. Cotan, you get tan, which is better. So secant of x, you'll get cosine, which is better. So these three functions would actually become better if you bring them to the denominator. So you want to do that. Next is a function where if you bring it to the denominator, you'll get something almost identical, right? E to the x, you get e to the minus x, and the derivatives are nice and they don't change. So this is pretty stable. So if you don't have something that wants to be in the denominator, you take this. And then if you start with a polynomial and you bring it to the denominator, you'll get a polynomial with, not a polynomial, you'll get a negative power. And when you differentiate it, well, it's not great, but it's not horrible. It's just going to increase power. Actually, let me put, sorry, I just thought of something. If you have a negative power, so here, negative power, here, let's put plus or minus, it doesn't matter. But if you have a negative power, then definitely bring it down. That would be something that would get better if you bring it to the denominator. And then you have things that get slightly worse, but that are still functions we know. So here, these will turn into those. not in the right order. Well, so these will turn into those, and so they get worse because we like cosine better than we like secant, but not much worse. And then the worst ones are all the logs. 1 over log, horrible. And then inverse trig, can you imagine having 1 over arctan? Oh. All right, so you try to avoid these. So better on this side, worse on this side. So go through the list. If you have something here and something here, that's the one you bring down. All right, so we'll apply this in the next video to evaluate a few limits.